Okay, 7 asked a question that was basically crazy, so I need to sketch one little thing. So by locally two-dimensional, I said the globe was a good example, right? Like, as you walk around, it's basically two-dimensional. Like, things are more or less flat. This is why we can't get rid of these flat earth cases. Okay, so 7 described a procedure by which we could take a couple of shapes and like cut them apart and then stick them together, and we might get a surface that wasn't orientable, right? You guys like followed that was the gist of what he was doing?
Yeah, I understand that's what he was trying.
Okay, so here's an example of like, here's a sphere, right? Let me stitch to the top of the sphere a plane. You guys all see this?
Okay.
Okay, so this thing is now not locally two-dimensional. Yeah, the reason it's not locally two-dimensional is literally just this one point right here. You guys see that? Where there's something flat and something curved up against it, right? I don't even know what it means to stand there. See that? So unless you give me some more rules for what it means to stand there, these things don't satisfy that. It's locally two-dimensional. It's almost locally two-dimensional, right? Like if you took the one point and threw it away, then I would believe you that it's locally two-dimensional. You guys see that? But if you take that one point and throw it away, it's not one object now, it's two. And then for each of those, you would have to pick an up and a down. You guys see that? And on the sphere, right, up I would just point as out from the middle of the sphere. And on the plane, I would pick either what looks like up in my picture or what looks like down in my picture. Either of those would be a consistent choice of normal. But because I took that bridge point out, there's not a way to go from one, like the plane, right? You can't get from the plane to the sphere. Does that make sense? So if you're going to stitch things together, you have to be really, really careful about what are called branch points. You guys see that? I'm not allowing you guys to use any branch points whatsoever in this class. Things have to actually be locally two-dimensional. And your book actually limits themselves to really convenient shapes anyway, for the most part. I'm going to show you a way to do it without the convenient shapes because I'm too dumb to remember all the formulas for the convenient